just a little bit about the meetup. We'll probably have these at least once a month. I think that's a good frequency, but we could have it more. We'll just see how it goes. But the idea is we're probably going to focus on C, C++ related to the meetup at first. There are different ways to program this part, and we might introduce that into the class as well because it's very flexible on how you use it. But like since our expertise is around that, and you can get the most out of it using C++, that's what we're going to kind of focus on. But there's other options such as Python and even other languages that you can use. So today the goal really is to get the tools installed and to get you the ability to flash an LED. So we're going to give everybody a board, and if you show us that you flash the LED with your laptop, you get to take it home. All right. So that is, you can eat. You can keep the pizza. We're not taking that back. You get to take, a real tool home that you can use in the next month to build something, which would be awesome.
Just like Oprah giving out free stuff.
What?
That's what you're just like Oprah.
Just like Oprah, yes. So I'm giving back. This company is giving back to the community. So. So I'm just going to start out with like a brief presentation. I have some notes on the Pi Pico. First of all, let's kind of see what kind of experience we have here. Who has used microcontrollers before? Yeah,
It's been a long time.
Okay, it's about half. And who is comfortable with programming? Okay, almost everybody. Who is using Linux? Anyone using Linux? Okay, that's great.
At the moment, or?
Oh yeah.
Right. Well, I think the general trend in engineering is things on Linux are easier now than things on Windows. And since I'm over 40, I use Windows. But I do use Linux too, but it's kind of a curse kind of. But I'm gonna do. I did it on Windows. Other people might have did it on Linux, but it should be easier for you. Okay, so I started my career in the 90s. I learned microcontrollers, or not microcontrollers, microprocessors, and we used 6800. And my high school teacher happened to teach it in this class, and we just typed in opcodes in assembler into Heathkit. And it was always pretty cool, but it was kind of inaccessible. Like you had this big board, and you could do some cool stuff with it, but just about that time, microcontrollers started to appear. 60HC11 came out, which is one chip. But then the only people that could buy them were like the car companies. And then finally, that became available sort of through student kits at universities. But it still wasn't a microcontroller in the sense where it had everything in the chip. So that just finally came out, and then the microchip came out, kind of became the first accessible microcontroller for everybody. And then, time goes on, things have been more accessible. They had the basic stamp for a while, which when I would see on a resume at college, I'd be like, oh, basic stamp, what a curse. Arduino got better, because at least it's C++, and then MicroPython is pretty hot right now. There's also some .NET stuff. Actually, a former person that worked at this company does a lot of .NET stuff. I think it's Madison Heights, so GHI Electronics. But what's great about the Pico is it's fairly accessible, and it's so accessible we're going to give you a free one. I'm going to publish this later. It's just my notes. But I think what's great for something like this, it's very simple. So the microprocessor in it, it's Cortex M0. It's one of the most basic, if not the most basic, 32-bit microcontroller. The cost is really amazing. The board itself that we're going to give you is $4. Don't tell the IRS. But the chip itself is under $1. Anyone can buy it. The debugger, you can actually use a second board as a debugger, so I think that might be something we want to do in a future class. I think a cruel joke they play on most introductory students is they give them the tools with no debugger. So if you look at like the basic stamp and the Arduino and Python, no debugger. Like, so anybody who's ever did embedded programming knows that when things, sometimes you're never going to figure it out without a debugger. So I just imagine someone who really wants to learn, is passionate, and just can't figure it out. And they can flash an LED or print some text, but you know, the Pico is really amazing in terms of community support. So if you look at the Raspberry Pi Foundation, I think it's 10 years now. So the fact that they came out with this, and there's just a lot of people, there's a lot of videos online, a lot of people use it. It's been out for about a year now. So that's really helpful. And also, in terms of simplicity, the documentation is excellent. So a lot of semiconductor companies, some of them realize and some of them don't, that pretty much most of their job is documentation. Like creating the chip, because you don't know what it's doing. It's just you power it up and then what's going on. And the only way you're going to know is through documentation and support. And I think that's why a lot of processors, they just use their home processor. So in Japan they use Renesas, in America we use Microchip. Germany they use like Infineon. Just because like it's really documentation is such a key part. Now sometimes the community comes along, like so you look at the ESP32, which is the Chinese part. It was just such a great concept. There was a lot of documentation created by the community, which for the Raspberry Pi Pico, it's also the same kind of concept. So things like porting from Arduino, porting from MicroPython, things like that. The flexibility of the part is pretty impressive. One thing I don't have on here is one of the most important features of any part these days. So
It may sound funny, but as Dave probably knows quite well, you try to buy like certain very popular microprocessors, or even just like voltage regulators. You probably have like banging your head, trying to ship products you can't get voltage regulators.
Yes. So like we make products here in that factory over there, and we might have 200 or 300 items on a BOM or more. And one part just goes missing forever, and then you have to redesign the whole product. And we went through that. We redesigned all our products a few times last year. And flexibility in terms of like, if you don't want to use C++, you can use Python. And like if you're doing a very basic application or you just want to learn about a sensor, it's really an incredibly useful tool. Problem with a lot of these quick fix type programming language like basic stamp or like Python, it's like it lets you get into a project real easy, but like once you're trying to do something serious, it works against you. It works, like it's not fast enough, or you can't move the data from here to there. It really breaks down. But it's great. Like you get a new sensor and you want to learn how to use it, write some I2C. There might be a driver already online, things like that. So. But the Pi Pico gives you the ability to do that. Interesting. The PWM is very interesting. I don't know if I've ever seen a part this small that has so many PWM channels. PWM is a way to create an analog signal from a digital signal, basically generating a variable with square wave, and it's used a lot for LEDs. You have 3 colors and you want to make any color. So
Pulse wave modulation?
Yes, pulse width modulation. Yes.
Wasn't sure.
So this part has 16 channels at the end for PWM. So there's 8 independent peripherals that share the same clock, but it actually can generate, each peripheral can generate 2 different duty cycles. So it's quite extreme. We've had a lot of problems getting LED drivers here, so we've got a lot of LEDs. So in terms of, I don't know if ST is building parts anymore, but we pretty much engineered all ST parts out of all our product. Well, I don't know if you want to short that stock, but dual core. That is so cool. This is the coolest thing. You know, at first you're like, what is that useful for? A lot of times you really care about timing in an embedded system. So, you want to like control like at the microsecond level when things happen. So if you have an application, it's very difficult to do that. There's all these tricks that they've come up with like it's not really tricks, it's how computers work, but interrupts and things like that.
At the microsecond.
What?
Microsecond, you said?
Yeah.
Okay.
Or sub-microsecond.
Okay.
Yeah. So, but what's cool is that you have this dual core. You could actually have your full application running on one core, and then the other core you can set it up in a way where they don't really interact in a way that delays the other one. So you could write, a C program that runs on one, and then you could write an assembly program that runs, and you control exactly when pins go on and off, like at the clock rate of the CPU. So there's always this thing called bit banging, which you do in a lot of embedded systems, mainly because whatever you're interfacing to isn't based on a standard like I2C or SPI or UART, which are the common communication standards for sensors or other systems. So you have to bit bang, which means you use the processor to control the pins and timing. And that's very difficult to do when you're also running code to do other stuff.
Does this fit into the ISO OSI model?
Yeah, that's what I wouldn't worry about that. It's just made to confuse students. No, I'm just kidding. But if you talk about, we're a network company, we talk about that a lot. But physical layer,
Yeah,
data link layer.
that's what you're talking physical layer, aren't you?
Well, it's not. It's really it would be data link layer because physical layer is the electrical nature of the OSI layer, and then how the ones and zeros are made, like the widths and spaces. That's the data link layer. So like Morse code, like if you were hitting a radio with Morse code, the radio would be the physical layer, where the way the dots are separated would be the data link layer. Yeah. So, but yeah, that OSI model. I mean, I get it, but it's just been around too long. And then finally, the Joule, which made me so excited. I actually didn't even look at this part when it came out because I'm like, oh, Cortex M0, this much RAM, blah, blah. But this thing, they created kind of a bit bang engine called the PIO, which is, I think it's revolutionary in terms of, I just think about all the problems I've had over the past 25 years with microprocessors, and they pretty much solved it. So why would you not use the Pi? It uses external flash. So what happens is this microcontroller does not have any memory in it. It has no non-volatile memory, which means when it powers off, it forgets everything you loaded into it. And what it does is it actually will run code off of an external part. Now, they engineered it in a way where it runs the code as fast as it can from an external part, but it really doesn't compare to what would be available in other parts. It's something else that has to go on your board. It's something else that's in your BOM. It's something else to go wrong. We've had a lot of problems with flash parts going obsolete. So we'll design a product, and then every few years we have to change our bootloader for the new part. So it's not exactly great. And there are 4-bit flashes, so they're 4 bits wide. So each clock will load 4 bits. Now they have like a cache in front of it to help your code, but it really comes down to is in certain situations when your code runs, it's going to slow down. And if you really want to get paid for your money, they can just pull it off your board and copy your code. So that's not very fun. But another thing you'll find in like a lot of microcontrollers, they'll actually have a very wide flash. So they'll actually read 128 bits of flash, for example, even though your instruction is only 16 bits. So that's how they take a slow flash and make it useful. This is kind of a huge one. It's not secure. Now, a lot of people say nothing's secure because you can hack it in some way, but security is all about building a resistance to hackers, and most hackers will give up at certain levels. So there's no way to protect your code at all. And I think that I get, like, coming from the Raspberry, I don't really understand why. I would like to know why, but they did it that way. I don't know if they ran out of time or it was a philosophy thing, but there's no way to, like, prevent anyone from coming. So, as someone who's had products copied in China, I would say it doesn't feel good. It does not feel good at all. So, and there's not really any, like, the government is not going to protect you. So it's just not a real thing.
So you're talking security, you're talking about the ability for somebody else to just like dump your flash.
Yeah.
Be able to get
Yes.
your
There's no security. So for purposes of this class, this part's great, but like that would be a major concern, I think, for a lot of companies to use it in a product. The USB is a full speed USB, so it's 12 megabit. I call that slow. Most people maybe not, but I think that high speed USB would be much more interesting. The PIO peripheral can really generate a lot of data, so it's kind of sad that it just has to be stuck in the part. Of course, there are high speed USB chips you could buy to attach it to, but that's going to cost. It's another part, more money. It doesn't have Ethernet. Ethernet is pretty much a standard on a lot of stuff now. There's only, I think there's only 30 GPIOs that you can use normally if you're using the flash. So there is a limit in terms of complexity. There's no floating point. The Cortex M0 is an integer-only processor, which they actually did a good job with. They did put a software floating point in the ROM, which helps your code sizes. It's not 5-volt tolerant, which is really annoying for people who are hackers, just because a lot of the sensors and things are 5 volts, so you have to have a chip in there that makes it compatible with the Pi. And then finally, it's not wireless. So now, of course, this part's 70 cents if you buy a real. So like, is it it depends on your application, right? For us, our purpose of learning embedded systems is great. Are you going to learn how to use C, how to use a linker, how to use I2C, how to use SPI, how to turn on an LED, how to all that stuff is the same with any part you use. It just happens that if we're going to do a wireless project, we're going to have to connect it to something else, which is fine. And I'm not complaining. It's pretty clear that they're going to have additional chips in the future. Like the RAM, like it has a lot of RAM, but you have to execute your code from RAM. So is it a lot? I don't know. But as software programmers, we always want the maximum amount of RAM, just because it makes everything easier. Back in the day when we programmed, I don't remember what the first PIC I had RAM. It was probably 256 bytes of RAM. I don't even know.
No, not even.
So.
I think it was less than that because I programmed I started out programming 16 C54s.
Yep, that's the first one. Yep.
Yeah. So I was gonna say, how many people here have actually programmed a PIC in assembly? You just revealed our age.
Yeah. Now the PIO peripheral of this part, Microchip kind of disappoints me because they should have added a few PICs in as peripherals to some of their bigger parts, and that would have just been a genius move because it's.
Yeah.
Anyway, so that's my presentation on the Pico. I hope that you're obviously already interested in it because you're here. So what we're going to do is we're going to hand out the parts, and then what we want you to do is follow this tutorial that's in the Meetup link. It's by Shawn Hymel, that might be how you pronounce it. But this is actually what I followed. And what you're going to do is go through the tool chain. So what kind of tools, I'll just briefly go through this. Like he suggests a specific directory. I would, unless for any other reason, I would just follow it. So when things go wrong, you can go back.
Contacts and stuff. You have like some, you have a link somewhere.
The link is in the meetup. Yeah, so the link is right here. Yeah, everyone's gonna download a gigabit file right now. So it might be here for a while.
I'll just let me talk about the steps. You don't follow these, but so you're gonna have a directory. You're gonna install the C compiler, C++ compiler, and that's just the GNU GCC compiler. So that's pretty cool. It's already compiled. These are for Windows, by the way. And you're gonna install the min.gw, which is kind of like a library for Linux type applications. You can install this stuff. I've actually installed this under the WSL, but the problem is USB support's not so good with WSL. So getting anything else working like a debugger is tough. Then you're going to use CMake. You're going to install CMake, which is basically that tells you how to build a makefile. It's kind of a generic way to build a makefile. I do not understand CMake very well, but I just follow the rules and it works. And then Python, you're going to install Python if you don't have it already. There's some Py files the SDK uses. And then Git, which is the source control that you should know real well. And then the Pico SDK.